In this example, we're going to take a look at the determinant of a 4x4 matrix. I decided to be super creative and just made it 1, 2, 3, 4, 5, 6, 7, 8 with several entries of 0 interspersed within what we see here. So what I'm going to do for this is I'm going to do a cofactor expansion. Because we have so many zeros in here, the cofactor expansion should go relatively well. I'm going to go across the first row. So notation that we'll be using for this, determinant of A is equal to A11 times C11 plus A12 times C12 plus A13 times C13 plus A14 times C14. So each entry multiplied by its corresponding cofactor. Now the 1, 1 entry happens to be equal to 0, so this term will 0 out, and the 1, 3 entry is 0 as well, so this term will 0 out. For the 1, 2 entry, we have a 1, but because of its relative position on the cofactor grid, that'll be -1 times the 1, 2 minor. So we eliminate the first row and the second column to yield the 3 by 3, 3, 4, 0, 0, 0, 6, and 7, 8, 0. This was 0 as well. The 1, 4 entry is 2. Based on the relative location of the 1, 4 entry, that'll be a negative from the cofactor grid. And then we'll get the 1, 4 minor in here. So that'll be 3, 0, 4, 0, 5, 0, 7, 0, 8. So that leaves us with only 2 more of these to evaluate. Now, as far as how I'm going to evaluate these things, I am going to do another cofactor expansion. I'd like to go down the third column for the first one. The reason that I'd like to go down the third column is because, once again, we're going to see some entries that wind up being 0. So we'll see a 0 times the, I guess that would be the 1, 3 cofactor in this case, plus 6 times that cofactor, the 2, 3 cofactor, and then plus 0 times the 3, 3 cofactor. Now for this one, you can either go down the second column or across the second row. I'm thinking down the second column would be just fine. So we get a 0 times the 1, 2 cofactor plus 5 times the 2, 2 cofactor and 0 times the 3, 2 cofactor. So copy in some more stuff down here. The 2, 3, that's an odd position, that would be negative according to the cofactor grid. So this will wind up being -6 times the determinant of the associated minor, which will be 3, 4, 7, 8. Minus 2 times, we have 5. Based on the relative location, that'll be a positive according to the cofactor grid, and the associated minor will be 3, 4, 7, 8, like so. Continuing to simplify as much as possible, we have -1 times -6, that'll be +6. This 2 by 2 determinant will be 3 times 8, minus 4 times 7. And we'll see -10 times this 2 by 2, that'll be 3 times 8, minus 4 times 7. Now continuing to simplify each of these, this will be 6 times. I see 24 minus 28. And once again, 24 minus 28 for this one. Simplifying this as much as possible, I'm seeing -24 plus 40 for a final answer here of 16. So cofactor expansion tends to work really well when there are lots of zeros already present within the matrix. If they're not already there, then in the next section we're going to discuss how to force them in there.